Hey, and welcome back to the channel, guys. This is part 4 of the DIY motion simulator platform build, the Dr ADHD 4-degree of freedom motion sim build. Let's talk about getting this welded on now. So, we're getting this lined up on the line that we've just scribed. This is an F clamp, guys, as in, the letter F. That's where it gets its name. This is a 150mm F clamp. This is quite an old F clamp. And this is how they work, all right? They basically have a vice-like action when it's clamped on your workpiece. In this case, we'll clamp it like this with the flat piece on the top of our angle, all right? And then this does up, guys, and when that does up, it skews this piece here and locks it, all right? That's how they work. This gets skewed as this gets tightened and it locks. So to do this up, guys, when you put it on, you don't have it all the way up like that when you put it on, or you'll have no adjustment, all right? Bit of common sense there. So this has to be wound out. I recommend you don't wind it all the way out, though, because that can get you in trouble as well. Have a little bit of thread through here so you can see this will oscillate, so it allows uneven surfaces. It allows you to clamp stuff on uneven surfaces. Now, when we clamp this will always go out with a clamp. You'll get this on your line, guys, that you've scribed. You'll put this on. We'll be using 2, one at this end. As I say, guys, make sure that your angle here is not only in line with where we've scribed our 5mm in from the edge of our box, but also let's get this flush on the front of our 65 by 65 box, and we'll screw this down firmly, guys. These have a fair bit of torque in them. 3mm angle, we're never going to squash that, all right? But the doctor is a bit paranoid, so I try not to over tighten this stuff. I don't want to flatten my angle. It's never going to happen with 3mm, but that's just me, right? And then we'll get our other clamp at the other end. We'll make sure that our angle is on our scribed line. So we should have, at the end of the day, guys, we should have a 5mm gap here where we've scribed and 5mm on the other side. Always just run your eye along, okay? And just double check. Your eye is also a pretty good gauge to just double check to make sure you've got things right. That's right, guys. There's nothing untoward with how we've lined this up. Now, often when you use a clamp, guys, when you clamp stuff, it will often put it out of position just by the very nature of you tightening it up. This is what we can do. Because metal on metal is very slippery, you can take a hammer to fine-tune your alignment with stuff, all right? I can tap this way and it will move, all right? The clamp will still hold it, but you can have small movements. So once you've got your clamps on both ends, go right along and double check that it's still in line with your scribe, okay? If it's gone out of alignment, you can just tap it back in, and this end is out a little bit. I can just tap that back like that. It's now back on the line. It will still move back on. I'm going to get down like I'm going to have a pool shot if I'm playing pool or snooker. And I can look straight down that line and I can see that that's on straight. Happy days. That's now clamped and we can get some tacks on now with our welder. But before we do that, guys, we've got to clean up that little bit of box under here. So we've got a nice metal to metal weld and we're not polluting our weld pool with this primer, right? And I'm going to show you how you can do that with a cut-off disc. Okay, guys, so yes, you can indeed use a nice thin cut-off disc, right? That's a 1mm job that we've spoken about. You can use that to very carefully, okay, get in between these really narrow areas, right? So the other thing that we could have done as well is I could have actually cleaned this primer off first before I scribed it. Though it would have been much harder to see the scribe mark on silver metal than what it is in primer. So this is a good way of doing this. And this is where you can employ a cut-off disc to get into really thin gaps and carefully, without cutting into stuff, you're using it really as a grinder now just to remove the primer, remove that primer. We've already got our angle completely clean, free of mill scale, so that's fine. We just got to get this primer off. Now, when we go to do this, guys, again, this is one of those scenarios where this can grab, it can get stuck in the gap here if you skew your grinder when you're doing this, all right? And it can grab your grinder and pull it, break your disc, cut into your box. You got to be really gentle, all right, and you're just removing the primer. Okay, can you see that, guys? I just went along there and I've basically cleaned that primer right where the weld's going to go in between our angle and our box. It's nice and clean there now, so we're not going to get any primer pollutant in our weld pool, and it's going to be a much stronger and better weld. Now I've got to do the same on the other side. I'm going to do that, guys, then I'm going to go through welding this on. Once that has been done, guys, just double check your alignment. Run your eye down the side, make sure you haven't cocked anything, kinked anything, the angle grinder hasn't bitten in, moved the angle a little bit. Double check, triple check, guys. So similar to the old adage, measure twice, cut once, we need to do the same when it comes to welding, all right? Now, sure, we can cut stuff off that we weld on, right? That's the beauty of metal, and then we can fix things with a welder. We can do all sorts of stuff with a welder. You're going to be loved in your neighborhood with a welder. Your wife is going to love you. Your friends are going to love you, and you're going to have a really full beer fridge and being able to be handy with a welder. But check everything, guys. You want to save yourself time and materials in the first instance. You don't want to be welding stuff incorrectly and crooked and then having to cut it off and weld it again. It's painful. Now, before I show you some welding techniques, guys, we are going to talk about something that is very important with welding, and that is your lungs, okay? So when we weld, we have a combination of the chemical reaction that's going to happen between our two metals, and we also have what's happening with our flux core wire, guys. It's emitting fumes that are not good for your lungs or for your body. So you need to have a well-ventilated area that you're welding in. For me, guys, I've got this really large door at the front of my workshop, and then at the rear of my workshop, I've got another door, okay? I have those doors open. Forgive the doctor's workbench. It is an absolute disaster zone at the moment because I'm well and truly in the work zone and the workflow for this sim build. Now, the other thing, guys, I have a really large fan that I have running when I weld, or I have an evac system that I built that I use on my metal bench here when it's not covered in shit when I'm doing intensive welding. Now, you guys aren't going to you guys more than likely will not have an evac system, and you're probably not going to have a really big fan like this. That doesn't matter, okay? I very regularly, let me see if I can find my little battery fan. You can use just a normal household fan, guys, and you can set it up in the vicinity of where you're welding. Here's an example of what I use frequently. Okay, this is a little battery powered fan, and I can sit this on something on my bench here, blowing air towards my door. That would be the way that I normally set it up. So when I'm welding along here, all the fumes are basically being pushed out and not coming in contact with my mouth, my nose, and I'm not breathing the fumes in. When I run my really big fan, it basically does the same thing. Because of where I've located the fan in the corner of my workshop there, guys, it pushes the air right around. It sweeps right around my workshop and then comes back around this way. You'll see, guys, I'll have it running as I'm welding, and you'll see the air just getting blown out the door. So just set a fan up, pushing the air away from where you are when you're welding, all right? That's one of the best ways that you can keep yourself safe from welding fumes. You can buy masks and stuff like that as well, no problems if you want to do that. I've been welding for 40 years. Okay, I've been welding for 40 years. I've never worn a mask. Maybe I'm lucky, but I've always had excellent ventilation, and I've always been really mindful of having a fan pushing the fumes away from where I'm welding. If you do that, guys, you'll be safe, and you should be okay. You should be okay. You'll never stand right over your weld and try and breathe it in deliberately. Well, if you do, guys, there's nothing I can do about that, I'm afraid. If that's what you're going to do, that's what you're going to do. I'm telling you not to do that. But if you want to do that, well, by all means, go right ahead. Okay, So what I'm going to do, guys, I'm going to set up my earth clamp, right? So this is the earth clamp for our welder, right? This is how the electricity travels through our metal and earths itself back. It's what creates the arc in our wire. And basically what happens is our wire here in our MIG gun, this does a combination of two things. The arc actually melts both of these metals because it's so hot, guys, right? It actually melts this metal, plus this wire also melts into where you're welding. So it's a combination of two things. You're basically melting those two metals together, and this is filling where you're welding as well. That's why when you weld pieces of flat together, ends of things together, if we were butting another piece of 65 by 65 into this, we would cut a V all around. Okay, so there's a V that we can feed weld into. All right, we do all of that sort of stuff. When it comes to needing to do those sorts of things, I'll show you how that's done. But because we've got a gap here naturally already made because of the way our angle sits on our box here, we've got a gap here that this wire is going to feed into, right? Our earth clamp, all right? It's just as important for our earth clamp to go on a clean part of metal as it is for our welding tip to go on the clean metal. I can actually even put this on my clamp here, guys, like that, all right? And that will earth to my piece of metal here, and I can run some tacks. Now I've just got to make sure my hose is free here, because last time I tried to do this, it wasn't free and I got jagged, and that will stop you from successfully being able to go along and do your tacks. So what we're going to do, guys, and this will be the case every time we come to weld pieces of metal together. Like I said, guys, it's a combination of clamping and tacking before we start laying some beads, what we call beads, or laying down some coins. You'll see what I mean when you see my weld. We're going to do some multiple tacks here, guys. We're going to tack back where we've cleaned. I couldn't clean back past the clamps, of course, but that's fine. I'm back far enough, guys, to the end to do a tack here. All right, so I'm going to do one tack here, and you'll watch me as I do my weld, okay? You'll watch how long I keep my welder in this position. It'll be roughly sort of, 5 seconds to do a good tack here. Then I'll come back, then we'll come back to this corner here, guys, and we'll do the same thing here. We'll put a tack in here, right? Diagonally opposite each other. Then I'll do a tack here, opposite that tack, right? Then I'll come back here, and opposite this tack we've done, I'll put a tack on this side. Then I'll put two tacks in the middle. That's going to hold our angle on there, and it's not going to go anywhere, and I can start doing my beads, all right? Now, guys, it's going to take you a little while to get to the competency that I can weld at, but I've been welding, guys, for 40 years, all right? So I can lay down a weld bead. I've had a lot of practice, and it's all just practice and muscle memory and technique, guys, and it builds as you practice. It's like anything in life, okay? It's not that I'm some amazing welder or anyone's an amazing welder. Sure, some guys might have a more of a steady hand or whatever. It's a matter of not being scared of what you're doing, okay? You get the right gear, you don't need to be scared. That leads me to this one, guys. Apart from our gloves, all right, and with MIG welding, you can generally get away with a lighter leather glove. You need a minimum of those rigger gloves shown in the Angle Grinder 101. All right, and that'll be fine with a MIG. You don't need the big gauntlet gloves that you use with stick welders, okay? Just those sort of gloves will do, and they will protect your hands, all right? You need a welding mask, obviously, guys, otherwise you're going to go blind, all right? And I highly recommend you get something like this. Doesn't have to have a skull on it or whatever. I've got a few different welding helmets. I've got manual one with a pop-up screen and pop-down screen. The problem with that is it requires two hands, right? This is an auto shade helmet. It runs off. It charges, okay? It's got a little solar panel in here, so it recharges itself, and it shuts off as soon as you start the weld. It's adjustable here as to how quickly it shuts off, or how sensitive the actual pickup is in it, because sometimes if you're outside in really bright sun, this will black out, even in the bright sun, before you even start welding, which is no good, because then you can't see what you're doing. So that's for adjusting the sensitivity. It's always going to show off straight away as soon as you start a weld arc, because they're so bright, right? You will literally go blind if you look into a weld arc. The advantage of an auto shade helmet is it just auto shades by itself, so you can have both of your hands free. So an auto shade welding helmet, guys, is an absolute essential, in my opinion, over a handheld mask or a flip down mask. If you get one of these, it's just going to make your job a lot easier. These can be had, guys, for around 50 Australian dollars, 60 Australian dollars, something like that, right? It's all included in my budget estimate at the beginning of the video. So get yourself an auto shade helmet. I'm putting this on my head because that's where it belongs, guys, when I'm about to weld, obviously. Right, you'll put your gloves on, most definitely. Now, my gloves, guys, are getting pretty sad, all right? These are getting pretty old. The doctor being Dr. Tight Ass, as he is, you know, I've got holes in these and stuff like that. I've got to be a little bit careful when you're welding. That stuff really starts to come home if you've got holes and stuff in your gloves, because you're not going to get the protection you need from gloves that are completely intact, all right? So I'm using these. They're not too bad at the moment, so I can get away with it. But these are getting close to needing to change these over, all right? These are getting close to having holes in them, and I'm going to start having issues with my welder because I have to be pretty close, all right? Because I'm using my hand as a rest, all right? Even with all my years of experience, if I was trying to free weld this, right, sometimes I have to, sometimes you just can't have a rest, but the weld is never as good as if I have a rest like this, okay? And I can use my hand as a rest while I do a weave, all right? You can see how I'm doing this circle motion. And when you weld, guys, you can pull, what's called pulling your weld pull. It'll just follow you, or you can push it, all right? It depends on how comfortable you are with either, but either of these techniques work. And it's just a little weave, guys. It's a circle that you sort of come back in on itself as the weld pull melts, all right? The speed of what you do the weave at is very dependent, guys, on your metal thickness. Because if you're going too slow and you have a thin metal, you're going to burn through your metal. If you have a thick metal, you need to go a little bit slower because it's going to take longer for the metals to melt together because they're thicker. Now, this is just going to be something that takes practice. And, you know, when I first started out welding, guys, I would sometimes just practice for a couple of hours on just some flat steel that I put together, like a butt weld, practice doing weld beads and stuff like that, even just on one piece of metal, just welding on the metal, you know, and practice doing weaving and weld beads, try to get it nice and even so there wasn't gaps, so it was a good, solid, consistent pull and weld, all right? So this is going to take you time, guys, to acquire the muscle memory and stuff like that. You'll be surprised, though, how quickly you pick it up. And, guys, you're going to have to pick it up if you're going to build this sim, because this is what you're going to need to do to get this stuff in place. But you'll pick it up pretty quick, guys. And if you use a MIG welder, it's going to make your life a heck of a lot easier. Right, I'm going to turn on my big fan, guys. It's very loud, all right? So it's a bit hard to talk over. I've literally got to yell to be heard over it. So I'm not going to be doing any talking when I'm doing this welding. I'm just going to show you how this is welded. So then you get the idea of what you do now with your welding. And this is pretty much, guys, rinse and repeat with anything that we're going to weld. It's all done in this way, clamped, tacked in a few areas, guys, to make sure it's in place and it can't move. Then we can take our clamps off and then we can put our proper weld beads in. So I'll get the camera set up a little bit of ways. We'll go here because I don't want weld splatter going on my lens. Otherwise, that'll be it for my camera. The phone will be kaput. Okay, MIG welder on. Now, I always set my welding voltage, guys, if you like, my amps, and my wire speed with an 0.8mm gasless MIG wire on this MIG. I set them both at 12 o'clock and then I adjust my speed accordingly to my metal thickness. I've got my big fan on, guys. It'll circle the air past here. You'll see the fumes and the smoke running out the door. I've got my auto shade helmet down. Before you start welding, guys, you can still see out of the lens. You can still see out of the lens. It's a tinted, like heavy sunglasses sort of shade, all right? Then as soon as I begin the arc, it just goes black, okay? But you can still see your arc but without being blinded. I want to try and get the centre for this weld because I'll run a bead basically where that is, so that's roughly the centre. Okay, now I'm going to leave my clamps on at the moment until I've done some beads, and what I'm going to be aiming for, guys, I'm going to be aiming for sort of 20 to 30 millimetre beads. So we're not going to just weld right along here in one big bead. We don't need to do that. We'll just use more wire than we need to. If we do 20 to 30 millimetre long beads with gaps of sort of 50 millimetres, that's more than enough strength to hold our trolley rail system on. That's getting pretty warm on my gloves, guys, at that vicinity, right? So, because these gloves are getting a bit old, they're getting a bit thin, I'm feeling the heat a little bit more. New gloves will get away with more of that. Keeping in mind, these are just a plain rigger's glove, okay? They're not like technically a proper MIG glove. A proper MIG glove will have a little bit of lining to give you a little bit of extra heat resistance. So, you know, maybe that's a good thing to start with. They're going to cost you a little bit more money than a plain set of rigger's gloves. I get away with rigger's gloves, guys, because I've been doing it for so long. I know what the limitations are. But when you're first starting out, maybe a set of proper MIG gloves with the lining will be better for you, okay? So that's my recommendation. So what I'm going to do, guys, I'm going to actually turn this around so I can get to the other side without leaning over it, because it's getting quite hot now. Now, guys, you could employ something like a decent workbench in lieu of a vise and some clamps, okay, some F-clamps to hold your material as well, all right? That's just by the by. I'm just going to clip this bit of wire off, okay, that fed out before I remembered to put my earth clamp on. And when I feed my MIG wire, guys, I always aim for about, you know, a 10 to 15 millimetre, oh, sorry, that's more 15 millimetre to 20 mil piece of wire protruding from my gas nozzle here. That's what I aim to sort of have when I start. Now we kind of have a bit of a mismatch of metals here. We've got a 2.5 mil thick box and a 3 mil thick angle, okay? So really, guys, normally what you would do is you would concentrate the majority of the heat into the thicker metal and push your weld pool into the thinner metal. We get away with it a little bit with RHS box, because with all box, guys, even though this is only 2.5 mil on the faces, it's always a little bit thicker in the corners. This probably blows out to be about 3 mil in the corners, so I can pretty much have an even placement of my weld pool between these two and still get a good result without risking burning through the lighter metal, okay, in this case. So now that I've got these on, I'm going to clean up here where the clamps were that I couldn't reach these areas before with the grinder. I'm going to do that, guys. I'm going to finish getting this welded. You've seen how I've done it. You can get an idea of the technique. I'll show you once the flux is cleaned off what you'll start to look at in a few months when you're getting more competent with your welding skills, and what you can expect in the future, guys. Heading down the road, once you've got all of this gear, a welder and stuff, you're going to really enjoy starting to do this stuff, and you'll get addicted to working with metal, to welding, cutting and making things, and you're going to come up with all sorts of projects. So you're just going to get better and better with your welding, all right? So anyway, I'll get this finished, guys, and then we'll come back and I'll show you the end result. So what you'll be left with, guys, after you've done your little weaves here, right, your little beads, you'll be left with flux, okay? Now, gasless MIG wire, unlike an electrode on a stick welder, it doesn't leave a heavy shell, okay? So generally, a wire brush will remove the flux. We'll remove the flux and you'll have a nice shiny weld bead. Once you get to a good level of competency with this, you won't need to be grinding your welds off, okay? You just won't need to. But what I recommend you use to remove your flux is this setup, guys. So again, guys, a drill, corded drill, or if you've got the money, you can get something like this. This again, guys, is a cheap Chinese Azito brand cordless drill. I got this as a set with an impact drive and a battery and a charger from Bunnings Hardware in Australia. So once again, this is like a Harbour Freight equivalent if you were in America. I think it was $89, okay? Now, I've had this drill so long, guys, that you can't even see the marks on it anymore, right? I've used this thing to death, doing this sort of stuff, hand drilling metals. I've used my impact drive heaps, guys. I built my workshop here. All my roof screwing, all of that sort of stuff was all done with the impact drive. Countless hours have been put on that impact drive for the money that was spent on that equipment, and it has done a good job, okay, guys? I've got more expensive stuff, but I tend to just buy this stuff and use it. Pay a little bit more money. Make sure you get at least a 4 amp hour battery, okay, because it'll just last longer. It came with a 2 amp hour or a 1.5 amp hour battery. Absolutely useless. 1.5 amp hour battery is not bad for this sort of work, but drilling and stuff like that, it's no good, okay? Doesn't really do that good a job. This will be very quick, guys, if you buy a little circular wire brush like this that goes into a drill. It'll remove the flux and stuff like that very quickly from your welds, and you need to get rid of that, guys. Flux is the thing that breaks down your welds the fastest. Obviously, we're painting our motion sim, guys, at the end of the build. It's going to look fantastic like the sim you've seen in the promo. And so this is what you need to do, guys, to make sure that you can get that painted and prepped for your painting. So this is how this runs. Now, again, guys, I would normally run my fan. Now, this is on slow speed from when we did that drilling earlier. I'm going to put it back up to a faster speed. And this is basically what you would do with all of your welds to get rid of the flux. I'll go through this, I'll do it, and then I'll give you a close look at the welds. Bear with the doctor here, guys. I've got to actually hold my camera. And unfortunately, when I bought this phone to do this video shooting, guys, for the 4 degree of freedom motion sim, I didn't do my research and I didn't get a phone that had anti-shake built into it. So unfortunately, I need to be as steady as I can with this, otherwise you're going to feel very ill. This is what you're going to be looking at, guys, when you get to a decent level of competency with your welding. Okay? And this is what you're aiming for. Good penetration between the two welds, and I can tell straight away when I look at these, I've got my temperature right, I've got my speed right. There's no cold welds there, guys. What's called cold welding, where you've just done a pool of weld and nothing's actually melted in. All right, that's going to be something that you are going to take time to learn. So I highly recommend, guys, as mentioned before, in my 3 degree of freedom motion sim platform, utilize that resource called the internet, utilize YouTube, and start watching welding videos, okay? Don't just take the doctor's word for it. You can watch welding videos and you can bring yourself up to speed with learning how to weld and learning all the techniques online, okay? But there is no substitute, guys, for practice. Now, when I finished cleaning off those flux areas, guys, I run my fan, okay? That creates a lot of dust with the drill or even just with a wire brush. Again, you don't want to be breathing that dust in, guys. Any dust is bad dust, okay? So run your fan, make sure you're pushing that dust away. And I'm going to show you what happens when you use a welder. I'm going to show you weld splatter and the beads that weld splatter creates, okay? You can see all of these little beads. See those little beads all on our metal here? Little ball bearings or beading, this is called, okay? Now that happens because we've got really clean metal near where we're welding. So those little weld splatters, guys, they just instantly stick to clean metal, okay? Now some of them you'll be able to flick off with your fingernail. Some of them will be bedded into the angle there and they'll have to be removed, okay? This is our bearing track. It has to be absolutely clean. I do this for all of my metal components anyway, and like I said, guys, we're painting this sim. We don't want to be painting over this sort of stuff, okay? And wherever you've got bare metal on your sim rig as you're welding it, you will end up with beading like this. Now, there are products you can buy for anti-splatter, okay? You can buy an aerosol anti-splatter. You spray it on your metal where you're welding and it'll stop the splatter from sticking, okay? It's quite expensive. All you need to do is go out and buy this. Good old canola cooking spray, guys, will do exactly the same thing. But we are painting our rig. If we use oil like that on our metal parts, it's going to compromise your paint. So for this, guys, we are going to have to mechanically remove all of this sort of stuff. And the way we do that is with our beloved sanding disc pad, all right? Very gently, we'll run over that angle now. There's no beading on the box because, as I said, guys, we're trying to leave as much primer on as we can because that kills two birds with one stone. It means that we don't have to add primer when we paint and it stops weld splatter sticking to our box, all right? But where we've got bare metal, you're going to have beading and weld splatter stick. And because this is our bearing rails, guys, we need to get all of that off so it doesn't cause our bearings to fail. But we've got to do it very gently with this. You don't want to gouge the rail or dig in at all. Just very lightly go over the whole thing and those beads will come straight off. So this is the last thing that you do in this step for our rails. You will now put that rail on. You'll flip your box over, okay, and you'll do exactly the same where you've marked it on the other side. You'll line up your 40 by 40 angle to those scribed marks. You'll get it clamped. You'll go through the whole process as I've showed you. And you'll weld these weld beads, guys. They're approximately 30 to 40 millimeters in length, roughly sort of 100 millimeters. They vary a bit. You can get the idea of how to get your trolley rail onto your box, all right? Well, that is your lot for today. So until I see you in the next tutorial, you guys stay safe, stay healthy, and take it easy out there.